Good morning, student. Subject Introduction to MEMS, chapter number 3, Review of Basic MEMS Fabrication. I am Madhuri Mulik, working as Assistant Professor in Department of Electronics and Telecommunication, Sharad Institute of Technology, College of Engineering. So previously we have seen the points from the chapter number 3, Review of Basic MEMS Fabrication. So let us take one review what we have completed in a previous session of chapter number 3. So deposition technique in MEMS we have covered. Then one example we have taken, that is MEMS pressure sensor, that is nothing but the deposition on a thin film of silicon nitride. Then we have seen what is deposition. Then we have seen what is the purpose of deposited layer. Then we have seen the types of layers which are used in a MEMS fabrication. So structural layer, sacrificial layer, conductive layer, insulating layer, protective layer, each stop layer, each mask layer. Then we have seen types of films. So here listed the thin films and its applications. Okay. Then we have seen one example of MEMS deposition process. So in this we have seen this is the 4 layers micro cantilever sensor. So cantilever structure, this is silicon nitride, gold and probe coating. So these are the 4 layers. Then we have seen the types of deposition process. So spin on film, thermal oxidation, chemical vapor deposition. So in that we have seen again 4 types also. So let us see spin on film deposition process, thermal oxidation deposition process. So this is nothing but the thermal oxidation deposition process. This is thermal oxidation furnace. Then steps involved in the thermal deposition process. Then third type we have seen the chemical vapor deposition. So in that what is homogeneous, what is heterogeneous, that we have seen. Then in detail we have seen the CVD process. So what are the steps followed in a CVD process, that we have seen. Then we have seen the types of chemical vapor deposition, that is APCVD, LPCVD, PECVD and HDPECVD. Then we have seen plasma enhanced CVD system. Then we have seen both 2 examples, that is LPCVD and PECVD. And we have seen how they are formed. Okay, so last thing we have covered, that is low pressure CVD and plasma enhanced CVD. So once again we are going to see this or summarize this, that low power chemical vapor deposition and plasma enhanced chemical vapor deposition. So this LPCVD operates at the temperature higher than the 600 degrees Celsius and PECVD operate at a lower temperature down to the 300 degrees Celsius. So a plasma is used to provide more energy to the reactant gas molecules. So the different operating temperatures can affect the quality of the thin film deposited as well as the applications. So the higher temperature of LPCVD produces layers with excellent uniformity of thickness and material characteristics. However, the higher temperatures result in a slow deposition rate and can be too high for certain films already deposited on the substrate. So PECVD operates at a lower temperature down to 300 degrees Celsius. However, the quality of the films tends to be inferior to processes running at higher temperatures. So LPCVD can batch process, meaning it can process at least 25 wafers at a time, Okay, so LPCVD can batch process, which will produce the 25 wafers at a time, and in PCVD just 1 to 4 wafers at a time. Okay, so LPCVD is used to deposit phosphosilicate glass, phosphorus doped polysilicon, and silicon nitrate. So PCVD is also used for silicon nitrate, but it's primarily used for films or wafers that contain layers of film that cannot withstand the high temperatures of LPCVD systems. So let us start the today's session with the next point from the chapter number 3, that is physical vapor deposition. So physical vapor deposition includes deposition processes in which the desired film material is released from a source and deposited onto the substrate. Okay, physical vapor deposition includes deposition processes in which the desired film material is released from a source and deposited onto the substrate. So this deposition method is strictly physical. No chemical reaction occurs at the substrate as with CVD. So the two types of PVD processes used in microsystem fabrications are sputtering and evaporation. Okay, so these deposition method is strictly physical. No any chemical reaction occur at the substrate as with CVD. So the PVD vapor deposition, it is only deposition method which is strictly physical. So there are two types of the PVD process. One is the sputtering and one is the evaporation. So PVD is normally used for the deposition of thin metals and metal alloy layers. Okay, so PVD is normally used for the deposition of thin metal and metal alloy layers. So for example, aluminum, Au, Ag, Al, Cu and Cr. So these thin metal layers are used for conducting layers and components such as electrodes, active piezoresistive layers, and for reflective material for optical devices. Okay, so these thin metal layers are used for conductive layers and components such as electrodes, active piezoresistive layers, and for reflective material for optical devices. So PVD is also used in construction of RF switches and coated cantilevers for devices such as chemical sensor arrays. So PVD is also used in the construction of RF switches and coated cantilevers for devices such as chemical sensor alloys. In CAS, a gold layer can be deposited on the cantilever surfaces prior to applying a probe coating. So for example, since gold is a relatively chemical inert, it can be used in biosensor to provide a functionalized surface for antibody anti-generations. Okay. So PVD is also used in a construction of radio frequency switches, coated cantilevers, chemical sensor arrays. So that chemical sensor arrays, that the gold layer can be deposited on the cantilever surface prior to applying probe coating. Okay. Then let us see the basic steps to a PVD process. So there are three basic steps to a PVD process. Okay, so let us see one by one. The source material to be deposited is converted into vapor. Okay, the source material to be deposited is converted into vapor either through evaporation or sputtering. Okay, then the second, the vapor is transported. Okay, vapor is transported across a low pressure region. Across a low pressure region. So from the source to the substrate. Okay, from the source to the substrate. So the vapor is transported across a low pressure region from source to the substrate. Then third is the vapor condenses on the substrate. The vapor condenses on the substrate to form the desired thin film. Okay. So there are three basic steps to a PVD process. The source material is to be deposited. It's converted into vapor either through evaporation or sputtering. The vapor is transported across a low pressure region from the source to the substrate, and then the vapor condenses on the substrate to form the desired thin film. Okay, so these are the three basic steps to a PVD process. Then sputtering method of PVD. PVD sputtering is a process by which atoms and molecules are dissolved. PVD sputtering is a process by which atoms and molecules are dissolved or ejected from a source material by high energy particle bombardment. Okay, so in sputtering method, atoms and molecules are deloaded or ejected from a source material by high energy particle bombardment. The rejected atoms and molecules travel to the substrate where they condense as a thin film. Okay. The ejected atoms and molecules travel to the substrate where they condense as a thin film. Then in a sputtering process, the basic sputtering process includes the following steps. So which are the following steps? The substrate is placed in a chamber with the source material followed by the target. Okay, so substrate is placed in a chamber with the source material followed as the target. The chamber is evaporated to the programmed process pressure. So usually in the high vacuum range. So the chamber is evacuated to the programmed process pressure, usually in the high vacuum range. An inert gas such as argon is introduced. So a plasma is generated using a radio frequency power source. So this causes some of the gas molecules. To lose an electrons, becoming positive ions. So plasma is generated using a radio frequency power source. This causes some of the gas molecules to lose an electrons, becoming positive ions. Okay. So these are the sputtering process steps. So sputtering method. So this is the metal with substrate target. Then the plasma. So bombarding of ions and sputtered atoms, that is silicon vapor. Okay. So substrate is placed in a chamber, the source material. The chamber is evaporated to the programmed process. Then gas is inerted, that is maybe that the plasma. Then a plasma is generated using radio frequency power. This causes some of the gas molecules to lose the electrons, becoming positive ions. Okay, so this is nothing but that the sputtering method. So the ions accelerated toward the target, which is at ground or negative potential. Okay, so the ions accelerated towards the target in this side, which is at ground or negative potential. So the high energy ions bombard the target, causing target atom to break off as a vapor. So causing target atoms to break off as a vapor. So the vapor expands and condenses on all surfaces. Okay, so the vapor expands and condenses on all surfaces. So the condensation forms a thin film. Okay, so condensation forms a thin film of source material on all surface, including the substrate. Including the substrate. Okay, so the vapor expands and condenses on all surface. The condensation forms a thin film of source material on all surface, including the substrate. Okay. So this is sputtering method of PVD. Okay. So this is nothing but the sputtering method of PVD. The next is the evaporation method of PVD. Evaporation method of PVD. PVD evaporation is a process in which a source material is converted to a vapor by applying high heat to the source. Okay, so PVD evaporation is a process in which a source material is converted to a vapor by applying high heat to the source. The applied heat is high enough to cause the source to boil and to vaporize. The applied heat is high enough to cause the source to boil and to vaporize. As with sputtering, a high vacuum environment is required. As with sputtering, a high vacuum environment is required. So such an environment minimizes collisions between atoms or molecules as the vapor expands to fill the vacuum of the chamber. So coating all surfaces, including the substrate. So such as environment minimizes collisions between atoms or molecules as the vapor expands to fill the vacuum of the chamber, coating all surfaces including the substrate. So such environment minimizes collisions between atoms or molecules as the vapor expands to fill the volume of the chamber, so coating all surfaces including substrate. So once on the substrate or any surface, the vapor condenses, forming the desired thin film. Once on the substrate, the vapor condenses, forming the desired thin film. Okay. Then evaporation process. So see this: silicon vapor, then vacuum system, metal source, metal vapors, and voltage source. So the basic evaporation process includes the following steps. So the substrate and the solid source material are placed inside the chamber. This is the substrate, and the solid source material are placed inside the chamber. The chamber is evacuated to the desired process pressure, usually high vacuum. So the source material is heated. So this is the source material which is heated to the point where it starts to boil and evaporate. Okay, where it is starts to boil and evaporate. So the evaporated particles, okay, so that is atoms or the molecules from the source, expand to the film the volume of the chamber, condensing on all surfaces including the substrates. The high vacuum allows the vapor molecules to expand with minimum collision interface. Okay. The vapor molecules condense on all surfaces including the substrate. The evaporated particles, atoms or molecules from the source expand to fill the vacuum of the chamber and condensing all other surface including the substrate. So the vapor molecules condense on all the surface including the substrate. Okay. So This is nothing but the evaporated process. What we have seen in evaporated process? It's very simple. Means the source material we are going to heat by applying the high voltage. So up to its boiling point, so it will start the evaporate. Okay, so metal vapors are, and in this chamber we have generated that the pressure as well as that the substrate of the solid source material. Substrates are here. So whatever the molecules evaporated, that condense in all the surface and also in including the substrate. Okay, so that is nothing but the evaporation process which is used in a EVD. Okay. So in this session we have covered evaporation process, then sputtering method. So in basic steps PVD we have seen so sputtering and evaporation. 2 points we have seen in this session. Thank you.